It's Friday. We made it to Friday, guys, and you have been working really hard all week. We've been doing the mock STAAR review since Tuesday, and I see some progress being made. Our mock STAAR is next Thursday, so we're less than a week away. And I know that weekends you guys enjoy to relax and have a lot of fun, but definitely this should be one of maybe 2 weekends in the school year that you actually study for your test next week. So you'll be able to take the review home and review it, work problems, double check, make sure you know how to do it, and really see what you need to be focusing on. So let's go ahead and get started. So number 1, Joe is renting a canoe at the lake this Saturday. The cost of the canoe is $25 for the first hour and $15 for each additional hour. Which equation represents C, the total cost for the canoe rental, and H for hours? So I'm looking for an equation that represents something. And I have an independent and a dependent variable. Let's see. The first thing it says is the cost is $25 for the first hour. So that's like a first time fee or a one-time fee. So what does that make you think of? Hopefully you said a linear relationship. So real quick, let's do a review of linear relationships. So linear relationships were y equals mx plus b, and you will see this on your formula chart, where y is our dependent variable, x is our independent variable. So that means, for example, maybe it's number of pounds of bananas that you buy determines the cost, right? So cost would be our dependent. Or, let's see, the number of tickets you buy, X, determines the cost, the total cost of all the tickets. And then M was our rate of change. So that's change in Y over change in X. And then B was, you guys tell me, our y-intercept. So remember, y-axis goes up and down. So think about how the y goes up and down. And then this one crosses through it. And the y-intercept is where, let's say this is our line. So the y-intercept, let me change my colors if this will let me. Sorry guys, I'm having major issues, Oh goodness. Hang on, keep. Current slide. Okay. There we go. Alright, so the y-intercept is where the line goes through the y-axis. So knowing that, let's go back and look at our problem. So we have initial fee and a first time fee. What are we going to do? What operation? Add, subtract, multiply, or divide. So if it's a one-time or a first time fee, we're going to add it. And then it says it's $15 for each additional hour. So if I see the word each, I should be thinking what? Multiply. Very good. So if I'm multiplying here, is that our, let's see, we know that our C is going to be our Y. Our total cost is our Y. And the rental hours are X. So I have 2 letters left. I have M and B. So M is right next to X. So that means we're multiplying. So this is going to be M. 15 is. And then B, we're adding it. So that's going to be our one-time fee. So let's go ahead and write it in y equals mx plus b. So y equals mx plus b. So y equals 15x, because it's $15 an hour, plus $25 for that first hour. And then it just goes ahead and tells us, so C is going to represent the total cost, and we said that's Y, so let me change this to C, and then I keep 15, and then 15 times number of hours, so they want this to be H instead of X. That's all I'm doing right now. All right, let me plug it in and see where I have it. So 15 here, and then 25 is with the H. We know that's wrong because we should be multiplying 15. Here I have 25 plus 15, H equals C. That looks good to me, but let's keep looking. H equals, we'll know H is the variable that we should be multiplying. Same here. So excellent. Our answer is B. Next problem. So it says, which problem is best represented by the equation 12 equals 12 plus 4x equals 30. So again, I have something that I'm adding and something I'm multiplying. So let me think back, and it should be y equals mx plus b. So you guys are really good at this, but let's put it in the format that you guys are familiar with. So let me put the 30 first. So 30 equals, and then mx, so 4x, and it's positive because it's a plus sign, and then b is positive too because there's no sign, plus 12. So now that I've written it in a familiar way, I am looking for a scenario where I'm adding 12 and I'm multiplying, oh darn it, okay, multiplying 4. So let's see, Laura spent $12 and then bought 4 boxes of erasers. If she had $30, how much does she have left? Well, if she spent 12, I would be subtracting 12. And that's not any of our scenarios. All right, he earned $12 babysitting and $4 an hour mowing lawns. If he earned $30, how many did he mow? Sounds pretty good to me because it's $12, so that's plus 12. And then it says $4 an hour, so that would be 4x. Looks pretty good to me. Let's keep looking. So he paid $12 for pizza and $4 for dessert and then bought soda. If he spent $30, how much did he buy on soda? Well, that I would be saying 12 plus 4 plus x is 30, and that's not our situation. All right, Esperanza earned $4 an hour babysitting, so $4 an hour says 4x. That's on the right track. She worked 12 hours. How many more hours would she have to work to earn $30? So she earned 4 an hour and she worked 12 hours. So I would be plugging the 12 in to multiply times 4. So that's not our situation either. So it looks like we have a winner. Next problem, Fidel had $50 to spend on clothes. He wants to buy a pair of joggers for $13 and spend the rest on shirts that are $8 each. Which inequality could determine how many, or the number of shirts he needs to buy? So you want to determine the number of shirts he can buy. He's buying joggers for $13. And then shirts that are $8 each. 8 each means what? Multiply. So we're doing $8 for each shirt and the joggers. So plus 13. And he has $50 to spend. So I'm going to put this here. Now, can he spend exactly 50? Yes. Can he spend more than 50? No. Can he spend less than 50? Yes. So I said less than or equal to. So he can spend less than or equal to $50. So let's find it. So 13 minus, oh, I'm sorry, this should be a 13. Okay, 13 minus 8. So are we subtracting the 8? No, we're adding. So that's gone. 50 minus 8. That's not what we have either. Let's see, 13 plus 8. So these two both have the first part we need, but their variable is signed, or is changed, or sorry guys. Sign is changed. So this one says that they're spending less than 50, less than or equal to. This one says they can spend more than or equal to 50. So we only have $50, so we have to go with C. Okay, which value of X makes the following true? So you have two options. You can either plug in all your values or you can just solve for X. I like solving for X. So I draw my line and I look first, I want to isolate 7X. So to get 7X by itself, I have to do the opposite to get rid of the 3. So plus 3 can be canceled out with minus 3, minus 3. These cancel and I have 7X left on this side. Let me go over here and do negative 14.5 minus 3. Well, if I think about it, I know I can't have subtraction with a negative sign. So I have to keep, flip, change. So same sign, I'm going to add it. So 3 plus 14. I know I just need to add that to there. So I have 17.5 and negative 17.5. So now I want to get X by itself. To do that, I'm going to do the opposite. Divide by 7, divide by 7. Going to go over here, 17.5 divided by 7. Let's see, 2 times 7 is 14. 35, need to move up my decimal. And then 5 times 7 is 35. And I know it's a positive divided by a negative, so I'm going to have a negative answer. So negative 2.5. There we go. Nice job. And which of the following equations represents the same relationship as shown on the graph below? Okay, so does this go through the origin, X and Y? No. So, but it's a straight line. So this is again going to be a linear relationship. So what we want to do with a linear relationship is find points on our line where the grid intersects. And then we need to create a table to find our rate of change. So X and Y. X here is 0, Y is 24. Move over here, X is 4, Y is 16. And then X is 8, Y is 8. Okay, so I know that with with linear relationships, I'm doing Y equals MX plus B. And M is our rate of change. So we're doing change in Y over change in X. I already know my Y-intercept. It's 24. So that's going to be my plus B. So plus 24. So let's see, I can already eliminate this because that's negative 24. This doesn't have 24. And then I need to find my rate of change. So first of all, the graph is going uphill or downhill? It's going downhill. So if we remember, that's a negative slope. So here it should be negative. So that's what I'm looking for. But let me double check. So my rate of change is change in Y over change in X. So Y minus this Y, right? We always move upwards, sorry. So 8 minus 16 over 8 minus 4. So 8 minus 16. So I'm going to add a negative. So I have negative 8 over 8 minus 4 is 4. 8 divided by 4 is 2. And it's going to be a negative because a negative divided by a positive is a negative. So I should have Y equals negative 2X plus 24. And that's what I found with D.